On numbers 1 through 4, you're asked some basic properties of exponential graphs. First, for number 1, you're asked what are the domain and range for the equation y equals 5 to the x power. So remember, any equation that's a positive number raised to x is going to look something like this, where, although you can't see it too well in this drawing, it intersects 1, 0. So remember, domain is our x values. Since we can see that this keeps going to the left and keeps going to the right, that means our domain is all real numbers from negative infinity all the way to positive infinity. Now our range, we can see that the values keep getting closer to the y-axis, but they never actually touch the y-axis. So that means our range is open parentheses 0. Open parentheses mean it never touches 0. From 0 all the way up to positive infinity, since the values start just above 0 and then keep going up to positive infinity. Now on number 2, you're asked what is one ordered pair on the graph of y equals a to the x. Since you'll see that this function, no matter what you put into a, it will always intersect this point 1, 0, because any number raised to the first power is 0. So the one ordered pair that's always on this graph is 1, 0. On number 3, we are asked why can't y equals 2 to the x power have an x-intercept, and this applies to any number instead of 2. It will never touch the y-axis, since the y-axis is our asymptote. And to have an x-intercept, it has to cross the y-axis. Since it can never touch the y-axis, it can't have an x-intercept. On number 4, we're asked that why can't y equals 4 to the x power, the function of x to the 4th power is an exponential equation, while x to the 4th is not. Remember, for something to be an exponential equation, the variable has to be an exponent. Otherwise, here, the x is not an exponent. This is just x to the 4th, which, by the way, is called a quartic function.